Alright, let me get you started on solving exponential and logarithmic equations, and then you can do some work on your own to figure out some of these. First, remember the key idea here is that logarithms and exponentials are inverses of each other. Okay, so let's take that idea when we go to solve these equations. I've got 3 to the 4x here, right? So 3 to the 4x equals 15. I need to get this 4x out of the exponent. So in order to cancel out this 3, I have to do the opposite of an exponentiation. What's the opposite of an exponentiation? Well, it's a logarithm with the same base. So what I'm going to do is I'm going to take the log base 3 of 3 to the 4x and do it on both sides. Just like if I wanted to cancel out, if I had 3x equals 15, what would you do? Well, you divide 3 on both sides. Why? Because that's the inverse of multiplication. Well, here, the inverse of an exponentiation is a log with the same base. So what happens? Those cancel. So 4x equals log base 3 of 15. Now, yesterday, you should have figured out how to plug one of these into your calculator, right? Log base 3 of 15. Let me pull out my calculator here. Let's see. So if you have a calculator with the older operating system, you can go log 15 over log 3. And for me, that would be log 15 divided by log 3. And I get, so 4x equals about 2.46. And then divide both sides by 4. And you get about 0.61, okay, or 62. So x is 0.62. All right. So once that exponential is by itself, you can take the logarithm with the same base of both sides and get your answer. Okay. So let's take that same idea over here. But remember what I just said, that exponential needs to be by itself. So let's get this exponential by itself. Let's subtract 3 on both sides. So 4 times 10 to the x equals 8. Divide by 4 on both sides. So 10 to the x equals 2. And now I need to take log base 10 of both sides. And if you remember, that's a common logarithm, so I don't need to actually write the 10 in here. That'll cancel. So I get x equals the common log of 2. So let's see what that is. Log 2, it's going to be some small decimal, I think. Yeah. It's about 0.3. Okay? So the way to solve an exponentiation is by doing the opposite, which is a logarithm. Same idea if I want to solve, take these logarithms. So what's the opposite of a logarithm? Well, the opposite of a logarithm is an exponentiation with the same base. So what I can do is I can take both sides and raise them up into the exponent. So 3 to the log base 3 of 2x, and remember you need the same base, equals 3 to the 4th. Well, the 3 and the log 3 cancel, so I've just got 2x equals 3 to the 4th. 3 to the 4th is 81. Divide by 2 on both sides, I get 81 halves, which is 40.5. Okay. Down here, so I can't raise them both to the e because these are separate logarithms here. What I need is I need one logarithm. So what I'm going to do, remember the property you talked about yesterday? If you've got separate logarithms being added together, you can combine them into a single logarithm by multiplying. So I'm going to go natural log of 5x, right? They're being added, so I combine them into a single one by multiplying. Now, what's the opposite of a natural logarithm? Well, it's an exponential with a base of e, right? Log base e is natural log, so I can go e to the natural log 5x equals e to the 1/2. Okay, so the natural log and the e are going to cancel over here, and I'll get 5x equals e to the 1/2. Let's see, what is e to the 1/2? Let's see, e to the 1/2. It's about 1.648 or 1.649 if I round it. Divide that by 5. X is about 0.33. Okay? So a couple key ideas with exponentials. Get the exponential by itself and then take a logarithm with the same base of both sides. With logarithms, you want a single logarithm on both sides. So you might have to do some combination or some condensing to get a single logarithm on both sides, and then you can exponentiate both sides in order to solve it. Okay? So go ahead and take those ideas and see if you can do the problems on the sheet.